Number 1. Okay, we're going to give you patterns on a table. You got to describe them, how fast they're growing, and then come up with a rule for each pattern. So your very first move, there's two types of patterns. There's linear and quadratic. So move number 1 is to see if you can figure out from each number how much it's changing. Is it going up? Is it going down? And how fast? So 12 to a -3, that is going to go down 15. 3 to -3, -18, that's going down -15, and it looks like it's going to be linear. So from each number to the next, it goes down 15. Okay, now that is your first hint that it's going to be linear. It's going to change at the same rate, but the question is it going down 15 every single time? And the only way to know is to look at this left hand side, and from the left hand side you see that the change from a -2 to 1 is actually up 3. 1 to 4 is up 3, 4 to 7 is up 3, 7 to 10 is up 3, and so on. So it does not really change 15 every time, it changes 15 every third time. So that's working 3 days and getting paid 15 bucks. But then I ask you, well, how much are you getting paid every day, not every third day? So to find the change, it's always rise over run. That's the same exact thing as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. These are all slope. These are all the same thing. So the very grandpa equation for all linear is y equals mx plus b. And what we're trying to find now is what we're going to times x by, what the slope is. So you are going to use a -15 divided by 3, and you should get a -5. Okay, that right there is the m. So you always divide your y's by your x's. So your rule is going to start off like this. I am going to times by a -5. So now let's test our rule out. So let's pick 1. What is 1 multiplied by a -5? 1 times by a -5 is equal to a -5. But the answer's got to be a -3, not a -5, so I'm going to have to adjust it. I'm going to have to go up. I'm going to have to add 2. So I'm going to test it with this one right here. What's 10 times a -5? That's a -50. Is a -50 add 2 a -48? Yes, it is. So my answer is times by -5, then plus 2, or y equals -5 times whatever x is, and then add 2. Okay, the next one is going to be quadratic. So this change from 17 to 3, that's going down 14. 3 to -3, that's going down 6. -3 to -1. Okay, now it turns around and starts to gain. So we're going up 2. 1, -1 to 9. We're still going up 8. 9 to 27. What's that? 18. And then 27 to 53 is 26. Okay, now I think I messed up right here. From a -1 to 9 is actually, it's not 8, it is up 10. Alright, okay, I hope that looks better. Okay, -14 to -6, that went up 8. -6 to 2, that's going up 8. 2 to 10, that's going up 8. 10 to 18, up 8. Okay, that's what I want to see. So my first time around, I found the numbers were decreasing, then they're increasing, so they're changing. But the second time, I found that they're going a constant rate, up 8, up 8, up 8, up 8. So because I had to go 2 times out, this is going to be a quadratic. That's my big red flag, that's my big hint. And I know this, every single quadratic has to look like this: ax squared plus bx plus c. So now my mission is, I've got to find a number for a number for b, a number for c. The number for a, and make sure you have this in your notes that you can use how to do this. A is going to be my 8, my constant change, this guy right here, divided by 2, always cut in half, so that is going to be 4. B, there's no way to tell from the table. C though, C is going to be right here. C is going to be whatever the answer is when x is 0. Okay, now the only way to find B is to use this equation, and let's plug 4 in place of A, let's plug a -3 in place of C, and then we're going to replace the y's and x's. So to do that, choose a pair, and we're going to choose x is 1, y is a -1. So I'm going to put the x right there and right there, and the y is going to go right there. So we're going to have this equation. We're going to have a -1 equals a, which is 4, times 1 squared plus b times 1 plus c, which is a -3. Okay, now let's clean that up. A -1 equals 1 squared times 4 is just 4. B times 1 is just b, -3. Okay, now I'm going to add up these numbers right here, 4 minus 3. So I'm going to go again, -1 equals 1 plus b. So what number plus 1 is equal to a -1? So I'm going to get b out by itself. I'm going to solve this equation. I'm going to undo the addition. I'm going to -1, -1. That cancels out, leaves me b. -1 and -1 is a -2. So b should be a -2. And now my final answer is y equals a x squared plus b x plus c. That is the function that describes that pattern. Okay, number 2. The diagram shows different designs the child's making by stacking blocks. So assume the design continues. Is this growing at a linear rate or a quadratic? Well, one way to tell is you can make a table. So this is a design and this is blocks. So design 1, design 2, design 3, design 4. Design 1 has 2 blocks. Design 2 has 1, 2, 3, 4, 5 blocks. Design 3, 2, 4, 6, 8, 10. Design 4 has, what's that, 3 by 5, so that's 15 plus the 2 is 17. Okay, so if you organize your data into a table, it's going to make the math pretty easy. Now all we got to do is figure out how fast it's changing. 2 to 5, that went up 3. 5 to 10, that went up 5. 10 to 17, that went up 7. So I know it is not linear. So it must be quadratic. 3 to 5 is up 2. 5 to 7 is up 2. Yes, it's quadratic. How do I know? Because my second change is constant. Okay, now this answer C is what we just barely did. They want the y equals ax squared plus bx plus c. So you can, from this step on, you can go ahead and find a, b, and c, and that is your model. That rule will continue this pattern. So it will, if you want to know what 5 is, it'll give you the answer. If you want to know 6, it'll give you the answer. If you want to know 205. If you come up with this rule will give you the answer for any number you want. So go ahead and you can do that, but I want to kind of show you another way. So look at the geometry of it. So what is design 205 going to look like? If design 4, I just want the dimensions. I want to know how tall and how wide 205 is. So I know it's going to have some kind of shape like this. I need to know how wide is it, how tall is it. So I look on design 4 and I see it's 3 wide but 5 tall. Design 3, so that's just this. I'm not counting these 2 blocks on the end. Design 3, if I ignore those 2 blocks, I see that it's 2 wide but 4 tall. Design 2, I see it's only 1 wide but 3 tall. So how wide is design 205 going to be, and how tall is it? So I'm looking at this number right here, design 4, and I notice a 3. Design 3, I notice it's only 2. Design 2, I notice it's only 1. So there's a pattern. The width is always 1 less than the design. So I know on design 205 it's going to be 205 minus 1. So it's going to be 204. Okay, now the height. Design 4 is 5 tall. Design 3 is 4 tall. Design 2 is 3 tall. There's a pattern there too. The height is always 1 more. So it's going to be 205 plus 1. So it's going to be 206. Okay, now on my calculator, if I want to know all the cubes in there, it's just a rectangle. It's the area. You're going to do 204 multiplied by how tall it is, 206. And that will give you 204 times 206. 42,024. But then you got to add these 2 blocks right here. So it's going to be 42,026. That is how many blocks are going to be on design 205. Now, you can even get the model from this without too much work. Because if you can draw the picture on 205, the picture for the model is going to be cake. I want design X. Okay, X represents any number I want. X can be 37, X can be 15, can be 1,000. So X is the number, the design number. So if I ask you to find out how many blocks it's going to take on design X, follow the same thing. How wide is it going to be? And it is always 1 less than the design. So if the design is X, the width is going to be X minus 1. It's going to be 1 smaller. Okay, the height is always 1 taller. It's always plus 1. So you take the design number, whatever it is, and you plus 1. So if my design number is X, the height is going to be X plus 1. And then I know there's 2 blocks right here. Okay, to get the area, you're going to take the base, X minus 1, times the height, X plus 1. And you should distribute. X times X is going to give you X squared. X times 1 is going to give you X. Minus 1 times X is minus X. Minus 1 times 1 is minus 1. And then at the very end I can plus 2, those 2 squares. Okay, in the middle, what's this going to leave us? If I combine these guys, X and a minus X, I think those just zero out. So you're left with the X squared plus 1. And you should get the same answer if you do it from the table. On the table you'll have A equals 1, B equals 0, C equals 1, So it's going to be y equals 1x squared plus 0x plus 1, which is the same thing as this. So do it either from the table or the geometry. Okay, another one. Let's do another one of these. For design 72. Okay, let's see if we can envision it. Let's draw kind of a rough sketch here. Okay, design 72. So let's try and find a pattern. Design 4. How tall and how wide is this? How tall and how wide is this? How tall and how wide is this? So design 4 looks like it's 4 tall, but it's only 3 wide. Design 3, it's 3 tall, 3 wide. Design 2, it's 3 wide, 2 tall. So from picture to picture, the base does not change. It's always 3 wide, 3 wide, 3 wide. So I'm going to assume this is going to be 3 wide. Design 1 is also 3 wide, and it is 1 tall. Okay, the only thing that changes is each design it gets 1 row taller. So design 4 is 4 tall, 3 is 3 tall, 2 is 2 tall, so that's easy. The height is going to be the same as the design. So design 72, that means it's going to be 72 tall. Okay, from picture to picture to picture, this never changes. There's always 2 squares right there. Now this changes. This kind of grows. How tall, how wide, how tall, how wide, how tall, how wide. On design 4, this is a 4 by 4. Design 3, it's a 3 by 3. Design 2, it's a 2 by 2. So on design 72, it's going to be 72 here and 72 there. So I'm done. Now all I have to do is find the area of this. Take the base times the height. 3 times 72. And you get 216 in there. 72 times 72. And you get 5,184. So 5,184 plus 2 plus 216. And you should get 5,402. Okay, now let's do it for any number we choose. So that one was just for number 72, design 72. So now let's create a model that's going to do all the math for us no matter what design we choose. So this is going to be design X. So design X, how tall, how wide is it going to be? Okay, I know it's going to be 2 there, and I know this is going to be 3 wide. And since it was 72, 72, I know design X is going to be X tall. Same with down here, this is just a square. It's the same dimensions as whatever design you're on. So on design 4, it was a 4 by 4 square. Design X is going to be X by X square. So now let's just do length times width of this top rectangle. If it's 3 wide and X tall, it's going to be 3 times X plus 2 squares right here plus this bottom square. X times X is going to be X squared. Okay, now when I go to add those up, there's nothing I can do because there's no like terms. So your answer is going to be the number of blocks is going to equal an X squared plus a 3X plus a 2. Question C. What grows at a linear rate and what grows at a quadratic? Okay, the linear rate is this right here. It is the rectangle. Because the base never changes. From picture to picture, the only thing that changes is it gets 1 row taller. So that is the definition of a linear. It is very predictable. Every time you're just adding a row of 3 blocks, plus 3 blocks, plus 3, plus 3, plus 3, plus 3. It's going to get 3 taller, 3 taller, 3 taller. Okay, quadratic. The square grows at a quadratic because it's getting taller, but it's also getting wider. So it's growing 2 ways. It's growing in length and it's growing in width. So it's not as constant. It's not always plus 3 plus 3. One time you add a row of 4 and a column of 4. Next time you add a row of 5, a column of 5. So it grows at a much faster rate. Okay, you can do the same. You can come up with this rule right here. ax squared plus bx plus c. The exact same as if you were to approach this by making a table. And this is the design, this is blocks. Design 1, how many blocks do we got? 1, 2, 3, 4, 5, 6. Design 2, we got 4, 5, 6, 7, 8, 9, 10, 11, 12. Design 3, you've got 40, 50, 60, 70, 80, 90, 20. And then count them for design 4, and then you can pick it apart. Plus 6, plus 8. See that it's growing at a quadratic rate. Then use your steps to find A, B, and C, and that will give you the exact same answer. Okay. If you are looking at this picture and you're going to be asked to explain what the heck is going on, if you've got a baby race, this is time. This is distance. And it's in yards. So this is 1 yard, 2 yards, 3 yards. It's kind of like an essay question. You got to explain what's going on. So 3 yards right here. Baby B. Let's do baby A, baby B, baby C. Let's figure out who's going to win. Baby A is going to finish. He's going to reach the finish line right here, which looks like it corresponds with 9 seconds. So baby A, this is seconds, this is yards. Baby A goes 9 seconds, 3 yards. Baby B, B is the dark black one. Baby B hits 3 yards, kind of between 5 and 6 seconds. So let's say baby B is 5.5 seconds. He hits 3 yards. Baby C is the dotted line. Baby C hits it right here, right at 6 seconds. Baby C is 6 seconds, 3 yards. And then baby D, the small dotted one. Baby D hits it at 9 seconds. Looks like he ties with baby A. So, if you're going to explain what's going on, you should say baby B wins. Then C is next, and it looks like A and D come and tie for last place. You got to talk about baby C and baby D. Baby C and baby D are crawling at a constant rate. So they have straight lines. That means as soon as they say go, that baby takes off at the same rate. He does not speed up, he does not slow down. He is just crawling at the same pace. Baby C, because his line is steeper, that means he is crawling faster than baby D. Okay, baby A, he's not steady. He's not constant. He starts out really, really fast. He's increasing. So he's getting faster and faster, but then all of a sudden he starts to slow down. Maybe he gets distracted. He slows down, he keeps slowing down. Baby D starts off kind of slow. The steepness of the line represents speed. So the more that time goes, that baby's getting faster and faster. He's crawling faster and faster. Okay, this picture right here, could it represent a function? Yes, because the vertical line test. There is nowhere on this graph, if I draw a vertical line, it only intersects the graph once. What is the domain? Okay, the domain is the left to right, the side to side. Oh, it looks like I erased it. There was an arrow there. So left to right, it is going to keep going. That arrow means it's going to keep going. So it's going to go all the way to negative infinity. but the right, it's going to come right here and stop on 6. And because it is not shaded in, it does not include 6. So it looks like it stops right at 5.9999999 forever. So I'm going to put a parenthesis around 6 and a parenthesis around negative infinity. So I interpret that it goes negative infinity to 6, and it does not include either one. C, the range, up and down. So it does not go ever lower than this, and it does not ever go higher than this. So up and down, the lowest it goes is 1, the highest it goes is 3. And I'm going to put brackets because it does hit 1 and it does hit 3. Okay, hot dog contest. How many hot dogs is he going to eat on day 237? 237 times 2. Or is it not times 2? Hold on. I think it's times 4. So the pattern looks like it grows like this. This is the day. This is hot dog day 1. He eats 4. Day 2 he eats 8. Day 3 he eats 12. So it does look like it's grown by 4. 16. So I can find the rule real quick. I know it's going up 4, up 4, up 4. So I'm going to times by 4. And I don't even need to do any adjusting because 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12. So my rule for B is this. To find the hot dogs, you take the day and times it by 4. Or y equals 4x. So 237 multiplied by 4, and that gives me 948 hot dogs. Okay, C and D are the good ones. C and D don't want to know how many hot dogs he ate that day. They want to know how many hot dogs he ate that day and every hot dog he ate since the very beginning. So they want the total number. So day 1, he's going to have 4 hot dogs. But day 2, he eats 8 plus the 4 he ate before, so that's a total of 12. Day 3, he eats 12 plus the 12 he ate on day 1 and 2, so now he is at 24 total. Day 4, he eats 16 new hot dogs, but he has eaten 24 in the past 3 days, so I'm going to do 16 plus 24, 40. Okay, stop right there. Now, as soon as you get 4 numbers into a table, you can figure out the pattern. So I'm going to see how fast it's changing. 4 to 12 went up 8 times. 12 to 24 went up 12 times. 24 to 40 went up 16. And I know that is not linear like this one right here. That was easy. Linear ones are easy. This is a quadratic. It's not as easy, so I'm going to go again. 8 to 12, that's plus 4. 12 to 16, that's plus 4. Now I know it's quadratic. If I know it's quadratic, I know it looks like y equals ax squared plus bx plus c. So I already know what a is. A equals 4 divided by 2. Can't find b right now. C I can find. But there is no 0. So maybe I cannot find C. If there is no 0, let's go back and make a 0. So I'm going to go backwards. Instead of plusing 4, I'm going to minus 4. 4 minus 4 is 0. So it looks like 0 is a 0, which is nice. Okay. Now I'm going to choose X and Y. I'm going to choose X is 1 and Y is 4. So now I'm going to go 4 equals 2 times 1 squared plus b times 1 plus 0. I guess I don't need that. So it's 4 equals 2 plus b. So what number must be b? B has got to be 2. So b is 2, a is 2. So my equation, my model for D is y equals 2x squared plus 2x plus 0. So now check this out. I did the model first because the model really reads like this: the number of hot dogs equals 2 times the day squared plus 2 times the day. So if I want to plug in 237, I'm going to plug it in right there. And I'm going to total the hot dogs equals 2 multiplied by 237 squared plus 2 times 237. So now I get my calculator. 237 squared, do that first. Plus, let's see, no. 237 squared times 2. Plus 2 times 237. So the number is pretty big. The number is 112,812. It's a lot of hot dogs. Okay, domain and range. I'm just gonna do a couple of these. Let's pretend on 13 this dot is not filled in. A is circled and shaded, B is not. So the domain is side to side. So that means you do include this, but you do not include this. So side to side, the farthest left it goes is -1, including -1. The farthest to the right it goes is 1, but not including 1, so it's a bracket. The range is up and down. The very lowest it goes is down here to a -1, and the very highest it goes is all the way up to 3. It does not include 3, but it does include -1. Okay, your domain on this guy right here. The domain, because it's not a straight line, that means it does not include anything between those dots. It only includes those dots. So your domain is not between something and something. Your domain is just actually side to side. It includes -1, it includes 0, it includes 1, it includes 2, and it includes 3. So I'm gonna put these in a bracket that looks like this, those 5 numbers. Your range is the same. It only includes 5 numbers. It does not include anything between those numbers, just those numbers. 15 side to side right here is the largest, and these arrows go forever. So my domain is going to be -infinity all the way to 2, and it includes 2, so 2 gets a bracket. The range up and down looks like it goes down forever, from -infinity all the way up to +infinity. Parentheses. Okay, finding rates of change. It's the change of these guys, which is +3, +3, +3, divided by the change in these guys, which is +1, +1, +1. So it's going up 3 over 1. On this one, you got to find a dot on the intersections, and then I connect those 2 dots. How far did I go up? 1, 2, 3. I went up 4. I went over 1. So it's rise over run. It's going to be 4 over 1, and I know it's a positive line, because if I go to the right, I've got to go up. Up is positive. Look at this line. If I go to the right, I have to go down. Down is negative. So this one is going to be negative. Connect 2 dots. There's a dot right there, and you cannot get a dot until right here. So how far did we go over and down? We went down 2, and we went over 1, 2, 3, 4, 5. You could do this. You could go this way. You can get the same. Over 5, up 2. So it's got to be 2 over 5, but it's negative. Okay. -3, 12, -11, -16. 12 to -16 went down 4. -3 to -11, that went down 8. So it's going to be down 4 divided by down 8. -4 divided by -8 is a positive 1/2. And last one, 0 to 6 up 6, 6 to 12 up 6, 12 to 18 up 6. But the left is not changing. The left The left is also going up 6, up 6, up 6. So it's going to be 6 divided by 6. Your slope is 1.